Now that we've got a pretty good handle on how to solve one and two step equations, we're going to take a look at some that are a little bit more complicated. So in section 1.4, the I can statement is I can solve equations with, we're going to write variables on both sides. So all of these equations are going to have variables on both sides, and we're going to start with a warm-up here that goes over some of the basic ideas that we've talked about before. So just a quick review here. Notice that we've got this long fraction bar here. We've got two terms on the top. We've got an x plus 3 here. So we're going to get rid of that division first. We're going to multiply by -5 on this side and on this side. We're going to do the same thing to both sides. Notice that those will cross cancel. We'll be left with the x plus 3 over here, and then we've got a -5 times a -2, and that's going to be a 10. Our final step to isolate the variable is going to be to get rid of this adding 3, so we're going to undo that by subtracting 3. So I'll subtract 3 on both sides. Notice that those are additive inverses, so they undo each other. So I've got an x left over here, and then I end up with a 7 on this side, so we'll go ahead and circle that answer right there. All set to go on that one. Next equation, you'll notice that our variable term is right here. So first thing we're going to do is we're going to get rid of this -5. So we're going to undo that by adding 5. So we're going to add 5 to this side and add 5 to that side. Again, those will cancel each other out. Those will add up to be a 0. So we've got a 1/7 x. So we've got that fraction coefficient there. And then we end up with -9 plus 5. That's going to be a -4. And again, we've got one step left to get the variable by itself. We've got a fraction coefficient in front of that variable, so we're going to get rid of that by multiplying by the reciprocal. So the reciprocal of 1/7 is 7 over 1. So I'm going to multiply this side by 7 over 1. And I'm going to put this over a 1. Remember, if there's a fraction in the problem, we might as well think of everything as a fraction. And notice what's going to happen here. We get to cancel off the 7 with the 7, so we're left with an x on this side, so we're in good shape there. 7 over 1 times -4 over 1, those are both just whole numbers, so it's a little bit extra that we wrote this 1 in the denominator of each one of these. But when we multiply a positive times a negative, we end up with a negative. 7 times 4 is 28, and then on the bottom, if we did multiply those, we'd have 1 times 1, which would be 1. -28 over 1, or -28 divided by 1, is still going to be -28. So we've got our answer right there. If we take a look at these next two problems here, we're combining some like terms like we learned how to do before. So let's run through and take a look at what we've got here. We'll just scan through here, and we'll notice that we've got some x terms, some y terms, some z's, and then we do have a regular old constant right here. So we're going to follow those general rules, that kind of convention that we write things in alphabetical order. So I'm going to grab the 2x and the 4x. We're going to put those together. Those are going to make us 6x. So again, I'm going to lightly cross those off. I'm then going to identify any y terms. So I've got this y term, a -5y, and then a plus 6y. No other y terms, so we're in good shape there. Let's combine those. We end up with a positive 1y. And again, I'm just going to write the positive y. And then we've got some z term here and a z term here, no other z's. So 1z, remember that's understood to be a 1 as a coefficient in front of the z. So a 1z minus 8z, that's going to be -7z. So we've got those taken care of. And then we can kind of see from the work that we've done here, the only thing that we've got left is that constant, and we're going to go ahead and put that constant on the end, and then we'll circle our answer. So that's combining like terms there. On this one, you'll notice that we've got some a's and some b's, and some with double variables. Remember, there's no good rule for where to write that double variable. So here's what we're going to do. We're going to write the a's first. We've got two of those. We've got a -5a and another -5a. So that's going to be -10a. Done with the two of those. We've got this one right here that just has a b. Remember, in order to be like terms, they have to have all of the same variables. This one just has a b, so we can't combine it with those other guys right there. So that's going to be a -5b. So we're done with that one. And then we put the two of these together. So we're going to take that 5ab and add another 5ab, and we end up with 10ab. And again, if you wanted to put that on the front, that would be totally fine. I kind of like putting it at the end. Really doesn't matter, but we do kind of follow that pattern of having them in alphabetical order. So we've got an A, then a B, and then an AB term there. Okay. All right. So let's take a look at some of these equations with variables on both sides. And just remember that when we're solving an equation, the whole point of solving an equation is to get the variable on one side all by itself. And that's a fancy way of saying isolate it. Isolate is the word that we use for getting a variable all by itself. And what that allows us to do is then we can read off the answer. We've got the variable on one side and the answer on the other side, so we can read off the answer that makes the equation true. And what we've done so far is every equation has just had a variable on one side or the other, maybe the left, maybe the right, but not both. So let's take a look at what we do if we have something like this. Now you've probably seen things like this before, so we just kind of want to remind ourselves of how we do this. We could move the 4x over to this side, or we could move the 7x over to this side. Now there's a way that would be best here, and I'm hoping that you remember what that is, but here's what we're going to do. We're going to move the 4x over to the other side. So I'm going to subtract 4x from this side, and I'm going to subtract 4x from this side. Remember, we want to do the same thing on both sides. I'm going to go ahead and draw a little line here like I did up above to kind of separate the two, and then we're going to figure out what answer we get here. Now what that's going to do is that's going to get rid of the x term from this side over here. So we're going to end up with a equals 3x on this side. Now I'm going to save ourselves a little bit of work by doing this. If we know the x is going to end up on this right side over here, let's go ahead and at the same time let's move this 3 over there. So let's do that by adding 3. So if we add 3 over on this side, again those are going to cancel each other off. We end up with a 12 over here. And then we're going to, of course, finish this off. We'll divide both sides by, divide by 3. I'm thinking of what the answer is going to be. So those cancel. So we end up with x is equal to 4. We'd circle that and we're done. Now, that is the answer. It will work if you plug it back in. It'll make the equation true. If we were to start off and do it the other way, so let's say we started off with 4x plus 9 equals 7x. And I'm hoping you remember what happens if we do this the other way. Let's say we move the 7x. Let's do that by subtracting 7x over here. So those are going to undo each other. And notice that we're going to end up with a negative 3x on this side. So we're going to go ahead and move that 9 over. So we're going to subtract 9 from both sides. So those would cancel, and then we end up with a negative 12 here. And of course we need to get rid of that negative 3, so we're going to divide both sides by negative 3. So we're going to cancel that, and we end up with x equals 4. Again, notice that we've got the same answer to on both of those, but this one tends to be a little bit better, and here's why. We're going to be less likely to make mistakes if we always move the smallest variable term. Okay, and I'm going to put smallest in parentheses because what we mean by that is we mean the variable term that is the most negative. Okay, and I'm also going to write this. I'm going to write furthest left. Okay, so let's say we were solving an equation that looked something like this. Let's say we had 7x plus 3 equals negative 8x minus 12 or something like that. Well, the question here is which of these two are we going to move? Are we going to move this one or are we going to move this one? And if we say the smallest one, number-wise, it kind of looks like 7 is smaller than 8. But remember, when we say smallest, we mean the one that's the most negative, the one that's the furthest to the left on a number line. So if we did a number line here, and 0's right here, and we put 7 right there, negative 8 would be about right here. This is the smallest one. And the reason we're going to want to move that one is take a look at what happens. If we move this one, we're going to add 8x to this side, and we're going to add 8x to this side. That's going to make this so we have a 15x on this side. We'd go ahead and let's move that 3, so we're going to subtract 3, and we end up with a negative 15 over here. The coefficient here is not negative. Notice that up here when we moved the bigger one, so 7x is bigger than 4x, when we moved the bigger one we had a negative coefficient, but when we moved the smallest one over here we end up with a positive coefficient. And so let's kind of summarize that. Why would you be less likely to make mistakes if you do the problem this way? We end up working with fewer negatives. It doesn't mean we're going to avoid negatives altogether. It just means we're going to end up working with fewer of them. And generally people make more mistakes with negatives than they do positives. So if we can avoid working with negatives, that's what we're going to do. So let's keep that in mind as we do these problems right here. Again, you've probably seen stuff like this before. You're probably familiar with this idea of moving the smallest one. And again, it doesn't matter if the variable ends up on the right side or the left side. We can just read from the variable and we've got our answer. So let's go ahead and do these problems. Let's see what type of answers we get. If we do happen to get a fraction or a decimal, we'll know how to deal with those. And again, a decimal, we're going to round to the nearest hundredth. So let's take a look at this one right here. We've got the 3x and we've got the 2x. Notice that each side is already simplified. So I'm going to go ahead and move the smallest one. That's the 2x. So I'm going to subtract 2x from this side and 2x from this side. Since we're going to get the variable over on this side, let's go ahead and get rid of that 5. We're going to do that by subtracting 5. So those are going to cancel. So we end up with, that's going to leave us with an x over here and a negative 3 over there. So pretty cool. In basically one line of work, we've got our answer there. And notice that this turned out to be a positive x. Had we moved the 3x over to this side, we would have had a negative x, and then we would have had to, change the sign of that coefficient and that sort of thing. So again, a little quicker if we move the smallest one. We're going to work with fewer negatives, tend to make fewer mistakes, and probably save us a step here or there. So again, this is what we were talking about up above. Let's go ahead and solve this one right here. I've got a 7m and I've got a negative 8m. Like we mentioned before, we're going to move the negative 8m, so I'm going to add 8m over here. I'm just going to go ahead and cross that off from that side because we know that's going to be gone there. And then we're going to get rid of the 1. We're going to do that by subtracting 1. When we move it to the other side, we do that by subtracting the 1. So we end up with, I'll put the equal sign here, we end up with 15m on this side, and then we end up with negative 29 on that side. We're going to get rid of the multiplying by 15 by dividing both sides by 15. And again, please don't panic if you come across a problem like this and you think, well, wait a minute, 15 doesn't go into 29 evenly. And again, don't grab your calculator because the original problem wasn't written with decimals, so we're not going to get a decimal answer for this. We're going to think of this as a fraction. So if it doesn't go in evenly, we're not going to think of it as a division problem. We're going to think of it as a fraction. We're going to say, hey, can I reduce 29/15ths? Well, they don't have anything in common. In fact, 29 is prime. We don't have any common factors there. So the answer on this one is simply the improper fraction, negative 29/15ths. Okay? All right, let's take a look at this one right here. We do have some decimals on this one, so we are going to be writing the answer probably as a decimal. Okay, I've got the calculator up, so we can use that to solve this problem right here. And we're going to go ahead and hopefully you figured this one out. Which one is more negative? This one is more negative. So we are going to add 9.25y to this side. So plus 9.25y here. We're going to add 9.25y here. Those are going to cancel each other out. The variable term is going to end up on this side. Let's go ahead and figure out what that is. So we've got negative 7.35. And then we're going to add 9.25, and we're going to hit enter. We're going to see what we get. So we get 1.9 over here. So on this side, and notice that it's positive, we get 1.9y. At the same time, let's go ahead and move that 12 over to the other side. So we're going to add 12 over here and add 12 over here. Okay, I'll go ahead and draw that line there. Again, those are going to cancel each other off because they're additive inverses. And then we've got negative 3.5 plus 12. Well, that is going to turn out to be positive. I believe that's going to be 8.5, but let's just go ahead and double check on the calculator. So negative 3.5, and then we're going to add 12. So let's just check and make sure. Yep, we've got 8.5 there. So 8.5 here and 8.5 there. Last step is to get rid of that multiplying by 1.9. So we're going to divide both sides by 1.9. Those are going to cancel. We get y equals, and then definitely a calculator problem here. Let's check and see what we've got. Now notice 8.5 is the last answer. So one thing that I can do that will save me a little bit is I can just hit divide. It's going to take that last answer of 8.5 and we're going to divide it by 1.9. So we'll hit enter on this one and let's see what we get. We get 4.473, kind of continuing on there. Doesn't look like there's a pattern to it that we can see so far or anything like that. So we're going to go ahead and we're going to round to the nearest hundredth. So the nearest hundredth would be 2 decimal places. So it's either going to be 0.47 or 0.48, and determine whether or not that 7 changes. Let's look at this number right here. It happens to be a 3. Remember, in order to bump this up to an 8, in order to round up, as we say, that's got to be a 5 or more. It's not, it's a 3, so we're going to leave that a 4.47. So we're going to say 4.47. If you wanted to put a little squiggly equal sign to kind of show that you rounded, that's just an approximate answer, that would be just fine. Okay, that should be enough. Should be in good shape for the assignment. Good luck.